שלום לכולם, ברוכים הבאים לעוד פרק של לנגטוקס. הפרק הבא הוא מיוחד כי הוא הפרק הראשון שלנו באנגלית, אז אני אעבור לאנגלית כרגע. So today we will speak with a special guest, Jesús. Hi.
Hello, great to be here.
We will talk about knowledge graph. We will take a use case, a really interesting use case that involve how you can really benefit from knowledge graph and working with LLMs. And we will talk about practical tips from like using knowledge graph in RAG application, construct knowledge graph using LLM, and then we will have a really brief conversation about what the future holds in this domain. So let's get started.
Today, Jesús with us. Jesús, you want to introduce yourself?
Sure, thank you, Lee. So yeah, I'm Jesús Barrasa. I'm the head of solutions architecture with Neo4j. So Neo4j is a graph database company, and I personally have been in the graph space for a good amount of time, probably the best part of my professional career. So I would say I'm an expert in knowledge graphs. I've recently authored with my colleague Jim Weber the O'Reilly book, Building Knowledge Graphs. So that's the most recent thing we've been working on. But I've been, in the graph space for the last close to 15 years, right? So I've been with Neo4j for the last 8, but before that I was working in another company called Ontology that used graphs also to solve problems in the telecom space. But yeah, data management person focused on graphs, and very happy to be here. Thanks for the invitation.
Great to have you here, Jesús, to share your insights from exploring and researching the world of RAG applications powered by knowledge graphs. I think knowledge graphs are getting more and more popular for LLM applications, while until now everybody were only looking into vector databases. Now knowledge bases are that are modeled in a graph is also getting some attention. Important to mention that LangGraph, which was released by LangChain recently, is unrelated to the topic of this episode, because LangGraph is more about orchestrating your chains and agents in a graph way, while knowledge bases are for your knowledge retrieval. So anyway, let's start with the motivation for knowledge base. And I guess we should look, for example, on this case of answering a question over a legal document.
Well, let's put it in context, because of course, your podcast is all about LLMs, generative AI, and is precisely in that context what we want to understand the value of graphs, right? Because that's relatively new for us. So Neo4j is a graph database platform that's been around for a number of years, but for the last 9 months, close to a year, since of course ChatGPT and GPT 3.5, 4, etc. was released, it's all about how we integrate with those systems, right? And somehow there's a perception that there's a good pairing, a good combination between the capabilities of large language models and knowledge graphs. So what type of use cases are commonly useful? And this one that you mentioned is a great one. Well, so we've all seen how taking unstructured documents, and a legal document is a great example of that. To build RAG applications, the natural thing would be to probably chunk it and put it in a vector database. Now, what we see, and maybe you've discussed that with some of your previous guests, is that that's a rather delicate approach, because you have to be careful about how you chunk, the size, how you replicate bits of information, and your decisions will have a significant impact on the kind of and the quality of the answers that you can provide. So what graphs bring in this type of use cases is additional context. So rather than just chunking the document in fragments and vectorize it so that you can do semantic search based on vectors, the graph will capture things like, in the case of documents, the internal structure of a document, right? A legal document, for example, This is in the context of a project that we run for a customer here in Ireland. So it was a legislation that contains parts. The parts contain sections. The sections contain definitions. The definitions contain clauses. So there's kind of these contains or part of, if you want, hierarchical structure. So when we chunk the document, we do semantic chunking, if you want to call it like that, and we capture in the graph all these contains relationships. So when we can do search, when we do search, we can then contextualize the answers and provide the relevant knowledge, the relevant context for the LLM to produce the answer. Maybe I'm going a bit too deep into the details. Maybe we're going to talk about that, but this is a great example. That's what we talk about. Creating RAG applications, natural language applications on top of unstructured data. But there's also a whole category of use cases when the data is highly structured. But let's go one at a time. So I hope that kind of gives a bit of context. Does that make sense?
Yeah, definitely. I think it's a very good example because, and there could be other similar examples like web crawling, or if you have a contract that you're signing. So maybe just to give a bit of a feeling to the listener. So assume that you have a contract that in the beginning of it says Lee and Gal are the one that have signed this contract, and down below it says everyone that have signed the contract should pay 1,000 shekels, whatever. So there is this reference that when somebody is asking a question about the document, like how much Gal should pay, you need to get both of these things, and it's not trivial to get them with a vector database. This specific definition that was done in the document is something very it's the business logic that many people and many knowledge bases have. So knowledge graph is just, I guess, an approach to index that in a way that is easier to retrieve.
So basically we have this knowledge graph that's helping the LLM in terms of retrieval, right? The RAG in terms of structured data or structured hierarchical document. But then you also have the LLM that can be beneficial if you use it to construct the knowledge graph, right? If we have entities, so we can try to use the LLM when we process the document to understand the relationship between entities. So this is constructing the knowledge graph. And then we can use the structure nature of this knowledge graph in the RAG application. Then retrieve not only the semantic most similar document, but also related document to this document, right? Okay.
Exactly. Yeah, you've touched, because it's a whole spectrum. So we've started with with RAG on the kind of consumer side. We assume that there's already a knowledge graph that we can use to retrieve the information, but the whole construction of the graph itself is something that the LLMs have really improved and simplified. I mean, we've been doing for many years entity extraction, right? There's been loads of NLP libraries that were doing that to some extent, but it's amazingly easy and good quality. I mean, being able to provide some form of ontology or description of the target model that you want to extract or build out of unstructured data, and then the LLM given that context, and that can come from querying the schema of the graph, or maybe it might be curated by your experts, but basically based on that and some natural language input, some unstructured documents, the LLM will build a knowledge graph out of that. So that's another great example of how LLMs have really improved not just the consumption but also the creation of knowledge graphs. Absolutely.
Maybe just a small emphasizing of the use case of the crawling, because this has come up every night and then. So basically, you have this crawling task that you want to apply LLM to crawl most the website, because this business that you need to perform question and answering on top is using the website to save his data. Maybe he has a FAQs section. Maybe have links from the FAQ to other pages that you need to process. So in this use case, basically, I have a side note here. There's a new tool called Clipper that basically take this HTML and convert it to Markdown, and then you also only retain the structure, that the structure base of the or the structure nature of the document, and then of course you can take that and ingest that to the knowledge graph, and you can perform like web crawling and then dynamically retrieve document that are linking to each other, and then perform better RAG on top of that.
Exactly. Yeah, because all those structural relationships, like a section within a section in the same document, or even a hyperlink connecting two documents, these are ultimately relationships. I mean, we haven't defined. I mean, we assume that people are somehow familiar with knowledge graphs, but graphs represent data, represent the world in terms of nodes and relationships. That these are all building blocks, and exactly what you describe. I mean, a document can be described as a collection of nodes representing the different parts of the document and connected to a root element that describes the document, right? So you have a contains relationship between them. And in the same way, you can connect parts to other parts through hyperlinks. These relationships are kind of native to graphs, and traversing them as part of the retrieval makes it a lot richer than just staying at the graph, pure vector search.
So I had until now a vector database that I indexed my documents. I did some sort of chunking and text splitting, and I ran different types of embeddings to improve everything. And now I'm faced into this new concept of knowledge graph, which sounds really interesting. And let's say I even implemented a knowledge graph. What's the mechanism, like how retrieval actually happens? Because with vector databases, we know it's just running this semantic similarity, performing some re-ranking, KNN. It's like a sampling mechanism to get out of the sorted list the most relevant documents and choose K of them. So how can you maybe elaborate, Jesus, on the process of knowledge graph retrieval?
Sure. Right. So a knowledge graph is a structured representation. So it's not just a list of vectors, is a set of connected things, right? And these things can represent either domain entities like individuals, events, locations, or they can be parts of documents like we were describing before. It can be really whatever you build into the graph. Now, this structure typically can be queried, and we have there's a number of standard query languages to query graph databases. But what's powerful is the combination of this graph exploration based on either just link navigation or querying of this graph structure with vector search capabilities built into the knowledge graph. So what you can do is, like we said before, nodes are the building blocks of a graph. Nodes contain a number of properties, right, that describe the internal structure of a node. These properties might be the actual natural language text. So you can embed that, vectorize it, and include it in a vector index. Now you can combine vector search pretty much like you do in a vector database, but then you can contextualize by navigating the relationships that connect the parts in the graph. So if you want to compare it, I mean, you can do the plain vector search and you're fine. You will get the same type of behavior. But what's powerful is when you contextualize. So based on the initial results, based on vector similarity, and that would be the typical cosine similarity, Euclidean similarity. Based on the highest scored ones, you can contextualize, and that means navigate out, explore, what these nodes are related to, because sometimes you will retrieve relevant information that was not part of the vector search results, but it's still relevant. And that's the example, for example, we're talking before about the legal document. Sometimes you have a definition of a term that you're interested in, and the definition contains 5 clauses. And if you do just return the chunk, the top match that contains the term itself, you might be missing these key clauses that are part of the definition, and that should be taken into context. So this kind of expansion of the result is what the graphs provide. So it's kind of an enriched approach, so something that builds on top of the vector search.
So knowledge graph is really suitable for like multiple documents, I would say, that involved in the RAG. I see in many use cases companies and people are like have to refactor their knowledge base, so every document, so to speak, is self-contained. So instead of having this, big document that reference one thing that references two other things, so they sit down, maybe with the help of ChatGPT, and just create multiple documents that each one of them is standalone, and then put everything into a vector database, which is flat. You can think about it as something with no hierarchy, and trying to find like the best single document that should be used. So I think as a rule of thumb, the more complex your context is, and the more relationships there are in the knowledge base, and the more documents you expect to your LLM application to retrieve for each question, the better you use knowledge graph than vector database.
Absolutely, you're spot on there. So the more important the context is, and the context being related documents, part of documents, capturing these relationships in a knowledge graph will be extremely helpful to provide the most precise and accurate context to the LLM.
So maybe, Jesus, if you can touch on like practically how in Neo4j, how can we use like your query language to retrieve document in use case of RAG application?
Sure. So typically when we build RAG applications that use Neo4j for the retrieval part, we will use orchestrators like everyone else do, right? These are the lang chains, the llama index, semantic kernel. I mean, you name it, right? And most of those already have integrations, provide connectors to Neo4j, both the graph and the vector index in Neo4j. So it will, from a code point of view, as a developer, the experience will be very similar, right? Instead of connecting to a vector database, you will connect to the vector index in Neo4j, and you will do the same sort of similarity search, where you pass a string, a natural language question that will be embedded, then a vector search will be run, and the results will be returned. The additional step there is that the vector index results in Neo4j can further be expanded. So basically, when you connect to the vector index, you can provide an additional contextualizing query. And that can be more or less generic, depending on the case, because you might want to build some contextualizing queries that are very precise for a very specific model. And in that case, you can write it in Cypher, is the query language that we use in Neo4j. But it can be more generic, based on patterns, or based on proximity analysis. So that's typically the way things look like. So we're talking about, because of the initial question from Lee, is like, how do we compare to vector databases, right? And typically the entry point there would be through vector search, similarity search in the vector space, and then expansion. But I think you mentioned, Gal, before, is that sometimes the retrieval part of a RAG application is not necessarily based on exclusively on the vector index, but also could involve the generation of a structured query. Sometimes you express a question that can be answered unambiguously by a specific structured query. So the LLM can play the role of translating this natural language to structured query. We've seen examples of LLMs doing generation of SQL. They're equally good at generating things like Cypher, and the approach is very similar. So they will query the graph to extract the schema, the ontology. They will introspect the graph, basically, which are the entities, which are the relationships, which are the properties within the entities. And based on this understanding of the domain covered by the graph, then the LLM can generate structured queries that will return the answer in a structured fashion, and that's the context that's passed to the LLM to provide the answer in the RAG application. So both approaches are valid, and both supported by the standard orchestrator that you are familiar with.
Yeah. By the way, this can be we are talking about a more like an agent that has the ability to query the knowledge graph. That can be an extra tool in the toolbox. So he can, for example, you can add a tool with a description. If you want to understand some relationship about entities, you can query the graph. So he can use this tool to enrich, but you can also use other tools, like it can be combined with calculator, or maybe, so you can create an holistic agent that has the ability to understand entities and relationship between entities.
Absolutely. There's another great example. I can probably share the link after, because one of our colleagues wrote a blog post about it, and it was kind of a support system, right, where there's information in the graph about teams, tasks, and the tasks are associated to projects. And there's in the task, there's a textual description of the task, and you can vectorize that. You can do vector search based on that. And if you have questions, the agent will determine this is a question about the task. But if it's something like, hey, which is the team with more open tickets at the moment? That's not probably answered by individual descriptions of the tasks, but it's something that you can answer with a structured query. So the agent will determine, well, that type of questions will be answered by translating that question to Cypher, and then the answer will be returned.
So I think at this stage of the episode, if you survived until now as a listener, probably you're curious about trying out this knowledge graph. And assuming you have all, like the typical listener have already has some experience with vector database, and let's say they're now working on a document of web crawled data. So, and they want to proceed with some kind of a POC. So for the vector database, probably they took like the titles and the subtitles and created like multiple documents out of this single page, and they have their vector database. And let's also assume that they have some they have implemented some retrieval metrics. So they can, like, given a black box that does retrieval, they can measure how good the retrieval is. So they would like to compare a knowledge graph to this vector database. Jesus, what tools or best practices you suggest for them to migrate or to create this first knowledge graph on the web crawl? And any other thought of how a good POC that migrates a vector database should be done?
Yeah, it's surprisingly not very different. I mean, you would go about pretty much in the same way. So I would say, if you want to go simple and not having to install anything, you can instantiate a Neo4j instance in the cloud. So you create a sandbox and you have an instance running. And you would probably, this chunking part where you say, I'm crawling the web or collecting a number of documents. So that would probably stay exactly the same. The only thing is that instead of chunking and writing to a vector database, what you would do is interact with the graph database. And then the primitives are just slightly different in the sense that you will create nodes and connect them to other nodes. So basically, when you create a new document, you will say something like create a node that represents the document. And that's the title. And that would be a property of the node. And then maybe the headline will be another property of the node. But then the node will have different sections. Let's say you break it down into the divs in your HTML page, or the sub, whichever way you choose, right? And these will be represented by other nodes, and the nodes will be connected to the container node through a relationship. And this is native to Neo4j. So you would interact with Neo in using Cypher, and it's as simple as create node and link it to another node. So it's very, very straightforward. Once you have it in the graph, you will determine which of the properties in your node, and that will probably be the natural language text you want embedded and persisted and indexed in the vector index. So that's another simple step. Create vector index and select the properties that you want indexed. Once you're there, you're ready to go. You have a vector database. In a way, it's a graph database enriched with vector index, really, but you can interact with it pretty much in the same way, except that now you have the possibility of, like I said before, expanding. And if you decide to go with something like LangChain, it would be pretty much the same, except that you will be able to inject these kind of contextualizing queries that enrich the results of your vector search. I hope I explained it. It's sometimes this is hard without having the code in front of you, but I'm sure we'll be able to share some references for your audience to have a look at.
Yeah, I think it makes sense. Just to add on this context, if you want to implement retrieval evaluation. We shared some knowledge in the previous episode about Raga scoring, which has the retrieval metrics of context precision and context recall. So just adding this.
So in terms of the GraphDB, do I use it as a vector DB also? And if I use it as a vector DB, what should I embed? Like only the nodes and the vertices? Like what should I do? How is it different?
I would say that there's two types of embeddings that you can create in a graph database like Neo4j. So there's a text embeddings, and these will be basically your choice is simple. I mean, you would embed the text content that you will want to be asking questions on. So if it's a web page, it will probably be the text part of it. In the case, for example, that I described before, when you have tasks like trouble tickets, maybe the description field plus the title plus the the start, the creation date. I mean, these sort of things. I mean, it's really up to you which fields you want embedded, but basically that's domain dependent. I would say is the ones that you want to be able to do semantic search on. That's I would say would be the natural way to do it. And then the other part is just the natural exploration of the graph.
So another point, this episode is of course not affiliated with the Neo4j or something, and how should, like, I want to speak specifically on how should someone consider, like, what consideration they should have when choosing a provider for their knowledge graph database. So what features are more important specifically for LLM applications, and other considerations?
Yeah, it's interesting because the RAG type of applications is very specific. I think it's important, for example, here, because I would say that typically, I mean, what our customers care about is things like performance, scale. I mean, both things are important. Although I would say that performance in this case, in a RAG application, in my experience, the retrieval part tends to be much faster than the generation part. I mean, so yeah, you might be 10 times faster than the competition, but ultimately, the LLM is going to take an order of magnitude longer. So this is going to be blurred by that. So things that I think are important, I mean, probably cloud-based. I mean, of course, you want to, more than cloud-based, I would say flexibility of deployment, because cloud-based is a good thing, but sometimes, you're not allowed to use public LLMs. For example, if it's confidential data, and that will happen in highly regulated industries like finance, energy. Some of these cases, they're just not allowed to use, for example, OpenAI. So they have to use an open source, self-hosted type of LLM. So probably one thing that's important is having a graph database that gives you the flexibility of having a cloud deployment or on-premise or self-hosted type of deployment. So that would be one thing. Another important element in the context of RAG is rich access control model. Because one of the things that you want to do is, we mentioned before that in a vector database, it's very hard to implement access control, because vectors are vectors, right? How do you determine which fields or which parts are accessible to who and what? So that it goes beyond the expressivity of a vector database. So in a graph, what you can do is, when you expand, you can use the built-in access control model to say, hey, this match actually is going to be filtered to you because you're so that type of user, and I can apply access control in that particular context. So probably a rich access control model is another important characteristic. What else? I mean, I think for any technology, it's important to have a good ecosystem. So a good experience for the developers. First of all, have good drivers, have good integration with. Here we've been talking about LangChain, Llama Index. So if you're going to be writing a RAG application, give me some good integration with this type of orchestrators, right? So that's another angle that I would also recommend to take into consideration, right? What does the ecosystem look like? What's going to be my experience if I go and try to build that? How hard is it going to be to build a team? How hard is to find the skills in the market? I don't know. These are some ideas that come to mind, but maybe you guys have other thoughts.
Maybe one other thought is that it's very useful that the language of the query is declarative. because then in the RAG application, it can understand really the query, right? It's not a new domain-specific language only for a specific. Like people can read it and understand it because it's declarative like SQL, so LLM can too. And it's very important if you use LLM to construct the query itself.
I want to take the access control that you've mentioned, Jesus, and what Gal has mentioned previously, like letting agent use knowledge graph as a tool to the last topic that we wanted to speak about today, which is the AGI. And specifically, if we could, like in the future, like limit the areas in the knowledge that agents could access according to what role they have, and not like letting all the knowledge to be available for everyone. So if we imagine like a team in the future of agent, that one of them is doing customer success and one of them is helping with the billing teams, and other they are developing features. So each one of them needs some access to our internal knowledge base, but not all of it. Just like people in the organization get the right permission. So I think this is an interesting point to have a look at.
I totally agree, because at least the way we see the knowledge graphs is, I mean, here, of course, for obvious reasons, we've been focusing on RAG applications and the integration with LLMs, but we see the knowledge graph as a system that outlives the different applications. So it's a way of collecting enterprise knowledge. And yes, in some cases, part of that knowledge will be relevant for RAG, for certain types of application. Some other will be important for supply chain analysis. Another one will be important for career path analysis for your employees. But in the end, the knowledge graph is a collection, is an accumulator of all the knowledge in your organization, and it's fundamental to be able to provide exactly access controlled and determine who can access which parts under what circumstances. So totally agree with you on that.
So as Lee mentioned, AGI. So I want to ask both of you maybe, what do you see, how the future hold for the memory or the vector database or whatever for the AGI, the memory system of the AGI? As people, we think in associative way, right? Because we think about something and then this reminds us something else. It's more like a knowledge graph or maybe a graph. But then the vector stores today is pretty flat and it's not really mimicking what we are doing. So what do you think about that?
I agree with you. I mean, to be honest, I think it's going to be a combination of the two. So, because yes, we think by association, right? We connect things to other things, and that's how and making that explicit is when we really understand things, is when we connect the dots, right? That's a way of understanding things. But it's really, really powerful as well to be able to determine that two things are semantically closed based on how they're used. I mean, the knowledge that's captured by a large language model, we've seen it, right? It's amazingly useful. I mean, the problem is that sometimes you know things, but you don't know why you know how you know them, right? And that is a problem in a number. I mentioned before highly regulated scenarios and industries. I mean, there are cases where you might have the perfect answer, but if you cannot explain and justify how you came to that answer, that cannot be applied. I mean, you might have the cure for a critical patient, but if it's too risky if you don't provide the and the same when you're making a decision on an important financial investment. I mean, we cannot trust the gut feeling, so it's always going to be a combination of the two. But I agree. I mean, it's hard to make a prediction, but it's really, really exciting times. And what's real is that it's closer to us than what we think. I mean, if you ask me 2 years ago, I would say I'll definitely retire before we get anywhere near that. And now I think no one will call me crazy if I say that we're going to see that in the coming 10 years, something like that. Maybe not, but no one will be saying, "Hey, guy, you're crazy," right? So Yeah, I don't know. What do you think?
People are underestimating the potential of technology in the long term and overestimating in the short term. So to wrap up what we spoke about today, we started with this legal document Q&A example, or web crawling or a contract, and we described the solution with vector database and then the advantages of using knowledge graphs. Then with this motivation, we defined knowledge graphs, and we started how to create your first knowledge graph and the mechanism of querying it. We also spoke a little bit about implementations and LangChain. So thank you, Jesus, for sharing your knowledge with us.
Well, thank you very much for inviting me. It's been I really enjoyed the conversation. So thank you. I hope your audience find it interesting as well.
Yeah, it was super insightful, and also our first episode in English. So thank you also for that, and see you all in the next episode. Bye bye.